and the maximum values depends on the system base and is 1 less than the base number. In computers, even fractional part also plays a vital role. It can change the operation of the device itself or any electronic device. 0 will not be able to attain. We cannot attain the 0 even if you continue till infinity. Hello students, welcome to the Digital Electronics session. I am Dr. Soumyashri from Department of Computer Science, Vidhyaashram College. In the last session, our topic of discussion was, or our topic of teaching was the number system, is it not? Number system where we use the number systems decimal, octal, hexadecimal and binary, is it not? Where decimal represents the base 10, the number octal represents the base 8, the number 16 is used to represent the hexadecimal, whereas the base of binary system was number 2, and the maximum values depends on the system base and is 1 less than the base number, is it not? This is about something about the topic of last session. In today's session, we are going to discuss about which are compared with computers, which are suitable for computers, uses the binary system, but the intermediate one is there where middle level language is there, which uses one of the system hexadecimal or octal. For that purpose, I have to talk about conversion of numbers with the interconversion between all the 4 number systems. Okay. To make communication between human representation and digital system, we have to study the conversion, because conversion is mandatory. For that purpose, we have to study the conversion. Okay. Here we have representation of conversion. As I have said, we can interconvert between any system. It is represented here. From any system to any system, you can perform the conversion operation. Okay. We have some general rules for conversion. What are those general rules is, the numbers how do you represent is, we have the integer part, number usually will having an integer part. What should be done if it is number is in integer part, only we have integer part. Well, how do we convert the number? Next is fractional part or decimal part. If you have fractional part or decimal part, how do you convert the decimal part? We cannot say that we'll convert only integer part and we'll omit the fractional part, because in computers even fractional part also plays a vital role. It can change the operation of the device itself or any electronic device. Fractional part is also a numeric one where we need to convert the fractional part to the corresponding number system. Okay. Here the number having integer part as well as fractional part. If it is with the integer part, we will be using successive division method. Division by 1 by 1 until we reach a conclusion. What is that conclusion? We'll be looking at that. Successive division must be done. Whereas for the fractional part, successive multiplication is carried out. Now, look at the general things or general points that should be remembered while performing a conversion. The first thing is integer part with successive division method. We have to successively divide the number. Divide the integer part of decimal number or any number. Divide the integer part by desired base number. Whatever base is of that number system, divide the integer part with that number, base number. Store the quotient and note down the remainder. Store the quotient. Quotient must be stored for successive division and remainder must be stored for final representation of the conversion. Now, we need both the quotient as well as the remainder. What must be done with the quotient? Consider quotient as a new decimal number. Now, the quotient becomes the new number for conversion and repeat the step 1. Again, store the quotient and note down the remainder. This must be successive. Until which part we have to continue? We need to continue until the infinity time? No need of that. We have to repeat these steps until the quotient becomes 0. One thing is, quotient must become 0. We have to successively divide the number until the quotient becomes 0 or quotient becomes less than the base value. If the quotient value becomes less than the base value, we can stop the division. Okay, that is one thing to be remembered. Until quotient becomes 0, either quotient becomes 0 or quotient value becomes less than the base value. At that position, you can stop the division, note down the remainder. Last step we have to follow is list the remainders in the reverse order, not from top to bottom. It must be listed from bottom to top. Okay, so this is the integer part. When it comes to multiplication or when it comes to fractional part, there will be successive multiplication. Here we are following successive division, whereas the fractional part follows the successive multiplication. Okay, in this, multiply the fractional part of the decimal number. You have to multiply the fractional part of the decimal number by the desired base number. Multiply it with the desired base number. Record the integer part of the product. Now we have to find out separate the integer part from the fraction, where we have the product. In that product, separate the integer part, record the integer part of product as carry for adding to the converted number and fractional part as new fractional part. Remaining fractional part will be considered for next multiplication. Repeat both the steps until fractional part of product becomes 0. It has to become 0 or it will become 0. Until then, you have to find out the multiplication or we have to find out the product. Or in most of the cases, 0 will not be able to attain. We cannot attain the 0 even if you continue till infinity. Infinite times if you multiply, then also you will not be able to get the 0 as the product. So, fractional part as 0. Then what I have to do? There is no end for the multiplication. We need to multiply until the time ends. Nothing like that. If the number fractional part will not attain 0, how much you multiply, you can stop the multiplication when you have as many digits as necessary for your application. Maximum of 3 digits or 4 digits or maximum of 5 digits. So you can stop the multiplication until you reach 4 digits or 5 digits. At that position, you can stop the multiplication. Read the carries downwards to get the desired base number. Now, it will be reverse the integer part. You have to from integer part from top to bottom. In integer part, it will be from bottom to top. Fractional part, it will be top to bottom. Okay. Now, we have an example of conversion from decimal to binary. Okay. Now, I have an example here, that is, we have 125 to the base 10. Number base is 10. It must be converted to the number which has the base 2. What does the integer part of conversion says is, you have to perform the, since it has only integer part, there is no fractional part, what must be done is successive division. Is it not? Here I have the representation 1, 2, 5 will be undergoing division by the base number to which you have to convert. From 10, I have to convert it to base 2. That means I have to divide the number from 2. If it is 8, it must be division by 8. If it is 16, division must be by 16. Okay. Now I have to convert it to 2. So I will divide the number from 2. Okay. I will get the quotient as 6/2. Okay. The remainder is 1. Okay. I will notify the remainder 1. Okay. Now this quotient will be the new number for division. Now again, divide the number by 2. Now in this case, the remainder is 0. Even the you don't get any remainder, you have to notify the, or you have to note down the remainder as 0, because binary only has 1 and 0. If you skip the 0, there will be change in the final result. So you have to note down, even though the remainder doesn't occur any remainder, you have to note down the remainder as 0. If nothing is there, 0 will be there. Is it not? Next, this 3-1 will be acting as new number, integer number for division. Again, divide it by 15. You will get the quotient 15. Remainder will be 1. Again, divide it by 2. 15. Get the remainder 1. Again, 7 divided by 2. Remainder is 1. Again, divide it by 2. Quotient is 1. Remainder is 1. Okay. Again, 2. You won't get the 2 because here you can continue until 0, because 1 divided by 2, anything cannot divide by less number cannot be divided by 2. So, you can stop the operation here because 1 is less than 2. When quotient becomes less than base number, you can stop the division. Okay. Now, How do you list out the numbers is from bottom to top, starting with the remaining quotient. Now this is the remainder. Okay. Now, or this one will be carried here. You can list out the numbers from bottom to top. We have the result 1, 1, 1, 1, 1, 0, 1. So here we have 1, 1, 1, 1, 1, 0, 1. Listing must be done from bottom to top. Okay. Here you have to notify the base, because sometimes when you use octal and hexadecimal, there will be confusion that what is the base, whether it is decimal or octal or hexadecimal. Binary will not be having any problem. Binary, as soon as you look at the numbers, you will recognize that the number is having base 2. The practice must be done to specify the base of the numbers. 10, 2, 16 or 8. You have to represent the base. Okay. Now we have few more examples for this. I will try out the first one. Okay. 41 or 41 is the number that has been represented in decimal. Now I have to convert this to binary. What must be done? Base is 2. That means divide this integer part. Only we have integer part. Okay. Successive division must be done. Divide it by 2. What we have? 2, 0 as the quotient, and the remainder is 1. Next we have 20 is the new number now. 2, 1, 0 is the new quotient. 1, 0 is the new quotient. The remainder is 0. Now we have 2, 5 is the quotient. 0 is the remainder. Now again go for further division. 2 is the quotient and 1 is the remainder. Again, I'll convert. 2 ones are 2. Remainder is 0. If you want, you can further divide. 2, quotient is 0, remainder is 1. How do you list out the conversion number? From top to bottom to top. Now I can represent this 4, 1 as 1, 0, 1, 0, 0, 1. The answer is 1, 0, 1, 0, 0, 1 to the base 2. Now are you clear? Divide, perform the successive division if it has the integer part. 4, 1, 2, 0, 1, 0, quotient, 5, 2, 1. Can divide it as 2, 0. Keep the last quotient as the remainder 1. Remainder is 1. 1, 0, 1, 0, 0, 1 to the base 2. Okay. So this is one of the example that has been shown here. Okay. Remaining 3 will be for you to get the answer. You try by dividing 348 by 2, successive division by 2, 4, 5, 6 again by successive division of 2 until you get the quotient 0 or quotient value less than base. If you are taking less than base, you start the counting from here. 1, 0, 1, 0, 0, 1. You can count like this also. Doesn't make any difference. Okay. Then 6, 7 to the base 10. Divide it by successive division by 2. Okay. These 3 numbers will be for your calculation. Answer for this will be given in the next session. Okay. Now, we shall be looking at the fractional part. How do you convert the number in fractional part to other base? Okay. Here we have the example 0.6875 to the base 10, which must be converted to the binary 2. Okay. Here what must be done? Multiply the number in the fractional part with the base to which we have to convert. Multiply it with 2. The value which we obtain is 1.3750. So 3750, keep it as the fractional part, new fractional part, whereas integer part will be represented for coefficient, for representing as conversion. Next, take this fractional part as the new fractional part and again multiply it with 2. Okay. In second successive multiplication, here the product will be 0.7500. That means there is no integer part. Okay. If there is no integer part, value must be mentioned as, coefficient must be mentioned as 0. Okay. Again, take this fractional part as the new one and multiply it with 2. Okay. Now, the value will be 1.5000. Okay. Now, again separate the integer value and keep it as coefficient in the position a to the power of minus 3. Okay. Now, remaining is 0.5. Again multiply it with 2. The multiplication value will be 0. Is it not? Now, fraction part becomes 0. Integer part will be 1. Note down it as 1 for the position a to the power of minus 4. Why it is represented as to the power of minus 1? Integer part, it will be to the power of plus, positive values. When it comes to fractional part, it will be minus. Why is like that? For example, if you take the number 1.5, this is fractional part. How do you represent it in the numerator and denominator part? So, this 1.5 can be represented as 1 by 2. Is it not? So, 1 by 2, or you can represent it as 1 by 2. Here, representation will be 1.5. This will be in the denominator. Is it not? Okay. So, 1.5 will be 1 by 2. This position will be the denominator. If you want to bring it to numerator, this will be 2 to the power of 0. How do you bring it to numerator? Is it will become, or if you take 2, it will become 2 to the power of minus 1. When you take that number to the numerator, the power of the value number becomes negative, is it not? For the same purpose, the values in the fractional part will be represented as negative value. That is to the power of 1, 2, 3, 4, minus 4, minus 5, minus 5, like this. Since fractional part carries minus value, it will be represented like this. It starts with minus 1 because minus 0 doesn't have any value. 0 has been included in integer part. To the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. So, 0 has been included in integer part. There is no meaning in representing as minus 0. Minus 0 doesn't have any value. So, the representation in fractional part starts with minus 1. Minus 1, minus 2, minus 3, minus 4, like this. Okay. So, this is an example for fractional part. Okay. For this, we have few examples. Okay, these are some of the examples for fractional part. We shall look at one example here. 350. Okay, 350. We shall divide it by 2. First, we'll do the successive division for integer part. 2 ones are 2, 2 14, 2 5s are 10, remainder is 0. Next, remainder is 1. Again we have 2. Remainder is 1. Remainder again is 1. Remainder is 1. Remainder 0. Remainder is 1. 2 ones are 2. Remainder is 0. 2. Quotient is 0 and remainder is 1. So, the integer part value will be 1, 0, 1, 0, 1, 1, 1, 1, 0. 1, 0, 1, 0, 1, 1, 1, 1, 0. Okay. This is all about the integer part. Now, about the fractional part, we have 0.5. Multiply it with 2, you will get 1.0, where integer part 1 will be considered for 1. Okay. So, it has attained 0 here. The value that can be represented is 1. So, it will be 1. Final value after conversion will be 1, 0, 1, 0, 1, 1, 1, 1.1 to the base 2. Okay. In the same way, we can perform the other examples where you have these many examples. try with other 3 examples. Once again, I'll give you the answer in the next session. Okay. Next comes is the example of conversion from decimal to octal. From decimal to binary, you'll be familiar or you'll be knowing how to convert the number from decimal to octal, is it not? Decimal to octal, here we have an example. 1082 is the number in decimal system. It must be converted to the number with base 8. Okay. Again, we have to perform 1082 divided by 8. Since conversion for converting, we have to convert it to base 8. That's why we are dividing the number by 8. Okay. Remainder is 2, least significant bit or the last bit that will be added in the number. Again 16, 7, 8 2s are most significant digit, where the counting will be done like this. You can again convert it like this. 8, 0, remainder is 2, 2082 to the base 8. Okay. Or you can skip the value. You can start counting the values like this. 2072. One and the same. There is no much difference in that. 2072. You can consider the successive division in case of integer part. Next, we shall have some more examples. I'll take an example 1836 of base 10. For this, we have to divide it by 8. The value will be 229 and the remainder is 4. Okay. Next, we shall perform the division. The remainder is 5. Okay. Next, again you can divide it or you can keep it like this. 8, 0, remainder is 3. You can count the numbers 3, 4, 5, 4 to the base 8. Okay. The remaining examples will be for you to exercise. Answer will be in the next session. Okay. Next comes is the fractional part. Again, same way, decimal number to octal. We have a fractional part 0.342 into 8. Count. When you multiply, you will get 2.736. 2 will be the first value to be added for the fractional part. Next is 0.736. This part will be considered as new fractional part into 8 results in the product 5.888. Okay. The value will be 5. 5 will be added next to 2. Again, this fractional part will be considered for multiplication 8, 257. Okay, again 0832 was the remainder. 0 was added. It seems that we cannot attain product 0, how much we multiply. For that purpose, we are stopping the successive multiplication for 4 digits. Okay, 4 digits is enough. If you see, it seems that it cannot attain 0, how much you multiply it, what we can do is stop the multiplication at 4th position. Okay. So this is the approximation, not the exact conversion. This is the approximation value of the number 342 to the base 10 to the base 8, 2570. What you can observe is, maybe in integer part and fractional part, the value doesn't exceeds 8. If you want to counter check the correctness of the answer, if the conversion value any digit, if it exceeds the base value, then you can conclude that there is a mistake in the answer. Okay, whatever may be the base, the converted result will not exceed the maximum value of the base. If it is 8, value will be, all the digits in the number will be less than 8. That is maximum of 7. Same with the hexadecimal, same with the binary, or same with the decimal. So the number will not exceed the base value. Okay. Next is the fractional number. We have another example of converting 0.356 to octal, where the fractional part will be calculated like this: 2 into 2.848, where integer part is considered for the conversion. Next, 0.848, 784, 272. Again, it is not considering or not attaining 0. Okay. In this case, the fractional part is stopped till the 6th digit. As I have said, based on the application for which you are using, you can either stop the conversion multiplication till 4 digit, or can continue with 5, 6, 7, 8. Okay. But minimum of 4 digit must be carried out. Okay. We have to obtain minimum of 4 digits after conversion. Okay. Next comes is the decimal to hexadecimal. Again, in the same manner, from decimal to hexadecimal, if there is a number from decimal to hexadecimal 2545, from 10 base, we have to convert it to base 16. You will get 159 to the base 16. There will be remainder of 1. Next comes is the 6. 159 divided by 16. We will getting the remainder 15. And 9, if it is divided by 16, we will get the remainder 9, quotient 0. Now 9, 15 can be represented as F. Is it not? 15 is greater than 9. So 15 is represented by the alphabet F. So the final result will be 9F1. Okay, to the base 16. Okay, we have another example where 10767 is the number where the remainder of first division is 672, which carries the remainder 15, where 15 will be represented by the alphabet F. Then 42, remainder is 0. Then 2, remainder is 10. 10 can be represented as A, 0, 2. So the final result is 2A, 0, F to the base 16. 2A, 0, F to the base 16. Okay. This is the conversion from decimal to hexadecimal. Okay. We have some more examples of this. Now, we shall take up an example 8193. Okay. 8193. This number in decimal must be converted to 16. So, what we shall do? 8193 divided by 16 will result in 512 with the remainder 1. Then we have the 512 which will be divided again by 16. The value is 3, 2 and the remainder is 0. Again we have 16 twos, remainder is 0. You can have 16, 0, remainder 2. The value now is 2, 0, 0, 1 to the base 16. Okay. This is an example of conversion from decimal to hexadecimal. Okay. When it comes to fractional part, how do you convert the number in fractional part of decimal to hexadecimal is again the same procedure. Fractional part 0.342 multiplied with 16, you will get 5.472. 5 will be the value that can be considered for first position after decimal point. Next we have 0.472 into 16, 7.552. 7 is the value. Next is 8. Next comes is the 13. Again, this is not attaining 0 at any cost. We shall be stopping the conversion till fourth position. 13 can be represented as D. So, the final value will be 0.578D. Okay. 5.78D to the base 16 is an approximation. Okay. So, we have an approximate value, not the exact value. Take the integer part and consider it for the conversion. Okay. We have another example of the value in decimal 374.37. Okay. First, we shall solve the 374, that is the integer part. Divide it by 16. Remainder will be 6. Again, divide the quotient 23 by 1. Remainder is 7. Now we have 0. Remainder is 1. The integer part will be 176. Okay. When it comes to fractional part, 0.37 into 16 will result in the value 5.92. Okay. This integer part will be considered for first position after decimal point. So, this 0.92 will be considered for next multiplication. Into 16 results in 14.72, whereas where 14 will be considered for next position after 5, remainder is coefficient is 14. the new fractional part is 0.72 into 16 results in 11.52. Okay, 11 will be considered as coefficient for the next position and 0.52 will be the new fractional part. 0.52 into 16 results in 8.32, where coefficient considered will be 8. Since again it is not attaining 0, we will stop our conversion till 4th position. Result will be 0.5 EB8. 5 EB8 from top to bottom. Final result will be 374.37 to the base 10. When it is converted to 16, results in 176.5 EB8 to the base 16. Okay, this is about conversion from decimal to hexadecimal. Okay, in the next session, we will be carrying out other conversion, that is from other base to decimal. In this session, we discussed from decimal to binary, decimal to octal, and decimal to hexadecimal. In the next session, we will be discussing the conversion from binary to decimal, octal to decimal, hexadecimal to decimal, and interconversion, binary to octal and hexadecimal, hexadecimal to octal and binary, and from octal to hexadecimal as well as binary. So, we will be discussing the interconversion in the next session. Thank you.